Okay, so we're going to see about the first topic. First topic, it is about the complex numbers. Subtopic 1 about the complex number itself, the learning outcome that you're going to learn from the first subtopic. Represent a complex number in Cartesian form. Okay, in Cartesian form, you just learn in the Cartesian form here. And define the equality of two complex numbers. So it's a definition here. The square of any real number is a positive number. Okay, as an example, if you're having third of 4, it will be equal to 2. Third of 9, it will be equal to 3. Or maybe you are having third of 2. Okay, if you try to press calculator, third of 2, okay, I'm sorry, should be calculating here. So third of 2, it will be equal to 1 point something, which is 1.4142 and something. And as we know, which is under the third, it must be a positive number, right? Positive any number. So it must be a positive. But what will be happen when you are having third of -1 or third of -4 or third of -9? So is it third of -9 is equal to 3? No. Okay, so it is no. So third of -1, do we have it? So if we try to press here third of -1, do we have any number? No, it is in the error. So if actually we are going to represent the third of -1. Okay, so what's the value of third of -1? Okay, third of -1, it will be equal to I here. Okay, so kita akan represent, we will be represent our third of -1 is equal to I. So this is imaginary number. So imaginary number ni apa dia? Which is we are having complex number. What is complex number? In a simple way, here's complex number is what? Z, it will be equal to A plus B, I. A and B is a real number and I is our imaginary number. So this is I imaginary number. What is imaginary number? Which is third of -1. Okay, so if you try to look at here, there is no real number that satisfies the third of -1, right? So therefore, third of -1 is not a real number. It is an imaginary number. So we are going to represent or denote it as a I here. So third of -1 is equal to I. So let's proceed, which is if you try to solve the I squared, it will be equal to -1. So kalau kita selesaikan dia, so if you try to look at here, which is when you are having third of -1 is equal to I, right? Then you are having third. How do we eliminate the third? So third of -1 is equal to I. We are going to square both sides. Square both sides. So third of squared here, it will become -1, and here I, it will become I squared. So I squared is equal to -1, and then third of -1 is equal to I. So this is things that you must be clear about before we proceed to the next the next discussion. So then the next one, if you try to look at here, we are having third of -4, right? So actually by using the third properties, we can have it in this way, which is if you try to look at the example, right, we will be having third of -4. We can have it as this one, third of 4 multiply with a third of -1, which is the result we will be having what? Third of 4, as we know, we'll be having 2. Okay, if you doesn't trust me, just put it here, third of 4. Third of 4 here, it will be equal to 2. So therefore 2. And we know that what, which is third of -1 is equal to I. So we'll be having 2I over here. Okay, so therefore there you are. And having the same thing when you're having third of -3. Third of -3, if you try to look at that, we can have it in this way, third of 3 multiply with a third of -1. Third of -1, yes, we know it will be equal to I. So therefore third of 3I here. Okay, so there you are. So, but please be careful. Third of -A is not equal to -third A. It is not equal. Okay, tak sama. Okay, when you are having third of -4, is not equal with this -third 4. So it is not equal. Okay, it is not equal. Okay, if A and B are negative, which is third A, third B is not equal to third of AB here. Okay, please be cautious about this part. Okay, so the which is the first and your outcome called represent complex number in Cartesian form, right? So this is the form that you're gonna have for our complex number, which A and B are real number. Contoh, let's say we are having some example over here. Z is equal to A plus BI, right? So let's say the A is equal to 3 and the B is equal to 4i. So this is your complex number. Okay, or maybe you want to have a pi plus with 3i, so this is your complex number. Or you want to have 4i plus with 3, still having the complex number. Okay, which is the most important. Of course, you are having I here. Okay, so let's proceed. Okay, real number A, which is A is called as a real part. So kalau tengok dekat sini, as an example, when you are having Z is equal to A plus BI, right? As an example, you're having 3 plus BI. 3 here, you are going to call it as a real part. As for this one, B here, since it is multiply or coefficient of I, it will be called as imaginary part. IM. Usually we are going to have IM there. So you can look over here. Which is, it is represented as the REZ, which is real number of the complex number, and the real number of B, which is coefficient of I, is called as the imaginary part, which is kita akan denotekan dia sebagai IM. IM is the imaginary for the Z, which is for the Z is for the complex number. RE we define as a real, which is the real for the real number for the complex number. Okay, so I hope you are clear about this part. So this is some notes that you can see over here. Okay, so kalau tengok dekat sini, real number is a subset of a complex number. Real number yang dah belajar banyak whole number and so on here, it is subset of a complex number. So complex number is the bigger one. Okay, so I squared is equal to negative I cube is equal to negative I. Okay, measurement kita dapat sebab kita tahu using the indices rule, I cube it will be equal to I squared multiplied with the I power of 1, which is I power of 1 is equal to negative 1, is it right? And I squared is equal to I squared is equal to negative 1, and I is I itself, so therefore you will be having negative 1, and I power of 4 is 1 itself. Macam mana boleh dapat tu? Sebab kalau kita tengok dekat sini, okay, we know that it will be equal to negative 1. I squared is equal to negative 1. Is it right? Okay, kalau tengok asal dia, patah balik sekejap, which is will be having square of negative 1 is equal to I. Saya dah explain macam mana kita nak dapatkan tadi, which is negative 1 is equal to I squared. So now when you are having I cube, it will be equal to I squared multiplied with the I power of 1, right? So I squared here will be having negative 1, and I power of 1 is multiplied with the I. So therefore you will be having a negative I there. So you will be having this one for the I cube here. Okay, so and then the next one, when you are having I power of 4, so I power of 4, what will be having here? So I power of 4 will be having I squared multiplied with the I squared, right? So I squared multiplied with the I squared, and then I squared is what? I squared is negative 1, so negative 1 multiplied with a negative 1, so therefore we'll be having 1. So that's why our I power of 4 is equal to 1 here. Okay, just some notes so that you can use it later. So next we are going to see example 1.1. Okay, we are going to discuss maybe only one question on example 1.1, and you are going to do the rest. You are going to do the rest since we already have the answers there. So I'm going to delete this one first. Okay, example 1.1. So if you try to look at example question A, we are having set of negative 36. So we are going to evaluate the imaginary number, right? So set of negative 36, if you try to press calculator, you will be syntax error. So what can you do? You can have it this way, set of 36 multiply with the set of negative 1, is it right? And then what's more that we're gonna have, which is we'll be having set of 36, it will be equal to 6, and then set of negative 1 will be equal to I. So therefore this is the answer. So you already got the answer here, and the rest B, C, D, I'm going to leave it for you. You already have the answers there. Try to do it until you get the right answer. Example 1.2, you already have the answers there. Actually, I'm going to explain. Okay, in order to compute I power of P, where P must be more than 4, okay, divide P by 4, okay, and obtain the remainder R. Thus I power of P for P more than 4 is I power of R. So apa maksud dia sebenarnya? Okay, kita nak simplify kan dia sebenarnya. Okay, tengok dekat sini we are having I power of 27. So I power of 27, kalau kita tahu, okay, basically tadi dah tengok dalam notes tadi, which is I power of 4 is equal to 1, is it right? So kalau kita tengok, kita ada 27. So now we are having I power of 27. So I power of 27, kalau kita nak bahagikan dengan 5, okay, kalau tak nak bahagi, in a rough way here, if you try to look at it, we'll be having what? I power of 4 multiply I power of 4 multiply I power of 4 multiply I power of 4. What's more? 4, and then we'll be having and continue I power of 4 and I power of 4 and then I power of 3. We'll be having 6 times, right? 6 times 4, 1, 2, 3, 4, 5, 6. 6 times 4 is I power of 6 times 4 is right, 26, right? Sorry, okay, 4 times 6 is 24, so I power of 24 here. So I power of 24 multiply I power of 3. So you'll be having this one, right? And then as we know, kalau tengok dekat sini, we already know that what, which is I power of 4 is equal to 1 multiply with 1 multiply with 1 multiply with 1 multiply with 1. So 1, 2, 3, 4, 5. Multiply with 1, and then another one multiply with I power of 3. So look at here again. So I power of 3 is equal to what? So I power of 3 is equal to negative I. So back to our example here. I power of 3 is equal to negative I. So therefore the answer is negative I. So are we having the same answer? Yes. So just a little bit different. The steps is a little bit different. So this is in harder way, macam orang kata jalan panjang. In a shorter way, that's why you are going to use what? You're going to use your division. That's why you can see from here 27. So I'm going to have some I'm going to draw some line here. So kalau tengok dekat sini, step yang dia tunjuk kat situ, which is 27. So 27 divided by 4. 27 divided by 4, you will be having 6. And the remainder is 3 plus 4. If you still remember, actually we are using the concept of partial division. Long division. Okay, long division is semester 1. So you will be having 6 plus 4 here. And then you will be having 6 plus 4. So what can you do over here? So kalau tengok dekat sini, the remainder is 3. So R is 3. So therefore, I power of 27 is equal to I power of 3. Kenapa tak ambil yang I power of 6 tadi? Sorry, I power of 24 yang tadi banyak-banyak ni, which is this one. Sebab I power of 24, tadi dah explain dah. I power of 4 multiply I power of 4, I power of 4, and so on here. I power of 4 here is equal to 1. So itu kita akan assume sebagai 1. That's why you can assume I power of 27 is equal to 3. Kita ambil a reminder je. Okay, reminder je. So therefore, it will be equal to negative 1 here. Okay, as for question B, you can try to do it again, redo it again. So kalau tengok dekat sini using indices rule, a little bit discussion. Okay, kalau soalan B itu, kalau tengok dekat situ, we will be having 3 power of 3, I power of 3 plus, plus I power of 50. So nanti cuba buka and then so on, and try to do it by your own lah. Okay. Okay, the equality of complex number between two complex number. Let's say you are having Z1 and Z2, A plus BI and Z2C plus DI. They are equal if A is equal to C, B is equal to D. So if you try to look at here, having some examples, example 1.3, the question asking to find X and Y for the equation for this one. So kalau tengok kat sini, our real parts, okay, the real parts, okay, real part is equal to X minus with Y, and then the imaginary part is equal to X plus Y. Then comparing with Y, okay, the real part here is given to 6, and then the imaginary parts here, X plus Y is equal to 4. You already have the two equations here. So this is the first equation, this is the second equation. So you can solve it simultaneously. You can have the answer for the X and Y here. So we are going to continue about the conjugate in the next video.